So if you're still here, that means you have questions, and that is a wonderful thing. On number one, they gave us two functions, and they're asking us to determine whether or not they are inverses of each other by using the method where we actually find the inverse of each one. Does the inverse of the first one come out the same as the second function? Does the inverse of the second function come out the same as the first function? So just take them one at a time. Using the four-step process that Mrs. Milburn told us about, we replace the f of x with y. And then, because we are reversing the process, we're working backwards, we're going to switch the x and the y. The x's are going to be the result, the y is going to be the input. And we solve for this new y value. So we can subtract 1 from both sides. And then we can divide both sides by 3. So y will equal, just going to divide each one of these by 3. So that would be 1/3 of an x minus 1/3. And the final step is to take this new y value and rename it as what it is. It's the inverse of the f of x function. And we were supposed to see, does this inverse equal the other function we've got up here? And yes, it does. So going this way, everything checks out. But you can't just do it one way. We have to also see if this function is truly the inverse on the g. So we're going to have to find the inverse of the g function. Once again, by replacing the g of x this time with the letter y. And then, because we're going to be working backwards, we're going to switch the x and the y. And solve for this new y value, which will ultimately become the inverse. It's going to add 1/3 to both sides. And then to get the y totally by itself, we can get rid of the multiplier of 1/3 by multiplying by 3, except that we have to multiply the whole equation by 3. So 3 times x plus 3 times 1/3, whoops, it's supposed to be an x, is going to equal 3 times 1/3 times y. Well, 1 times y is just going to be y. And we rename this new y as the inverse function. So g inverse of x equals 3x plus 1. Is that inverse the same as the other function, the f of x function? And yes, it is. So f of x is the inverse on the g of x, and g of x, we found out, is the inverse on the f of x. They are inverses of each other, and that's what we were trying to find out. So using the graph, we're going to graph each of these original functions. And if you remember, if they are true inverses, they will be reflections across the diagonal line y equals x. So since I've got the orange marker out, I'm just going to start with the original g function. So that's got a y-intercept of -1/3, slope of 1/3. So -1/3, up 1 across 3. Up 1 over 3. Up 1 more space over 3. Likewise, going to the left, we can go down 1 and to the left 3. Down 1 and to the left 3. Down 1 more and to the left 3. And I think I counted wrong. I did. Down 1, left 3 would be here. And then down 1, left 3 would be here. I'll just stick an arrowhead there. And this orange one was supposed to be the graph of our original g of x. Likewise, we're going to graph f of x, which is even simpler. Y-intercept is positive 1. The slope is 3, so we'll rise 3 across 1. Rise 3 more across 1. Rise 3 more and across 1. Or we can go down 3 and left 1. Down 3 more, left 1, down 3 more, left 1. You get to see how it's gone. Oops. And this should be the graph of f of x. Now, if they are truly inverses, and I could draw straight lines, they should be a reflection across this diagonal line here at y equals x. And it does appear that they are. We could pick some checkpoints and see if they were the same space. This point, when x equals 0, y equals 1, and that would fit in here. This point looks like it's when x is 1, y is 0. And if we put a 1 in the g function here for x, we'd have 1/3 minus 1/3. Yes, it does come out to 0. So it looks like the graph does verify our algebraic method. The second algebraic method is this one that's the composition of the functions. We're going to find f of g of x, and then we're going to find g of f of x. And we're trying to see, will the two functions cancel each other out? Will the equations disappear and we're just left with x? So we'll give it a try. Going to find f of g of x, simply because that one's listed first. So that's going to be f of whoever g of x is. And we are going to put that in the f function, right there. So all of this is going to be placed in the f function for x. So we have -2 times this whole thing here. And that just takes care of the -2x. We still have +1. Now we can cancel out these 2's. We would still have the opposite of -x plus 1. But this 2 and this 2 will cancel out. And we have the +1 on the end to bring down. And then if we take the opposite of whatever's in the parentheses here, so that make this positive x and a -1, and we still have the +1 to bring down. Well, that just comes out to x. So the f function and the g function did cancel each other out. This part works. But as always, to see if it's an inverse, we're going to have to see if it works both ways. So we'll have to find g of f of x. So we're going to take the entire f function here and put it in and then evaluate it at g. So that was just substituting the f of x function in for f of x. So that means all of this is going to go into the g function right here. And we'll still have the negative, we'll still have the plus 1, we'll still be all dividing by 2. So it's going to be the opposite of, got this negative sign here, whatever this is. So that took care of the x, and now we have a plus 1 after that, and it's all being divided by 2. Well, to simplify, we can take the opposite of whatever's in this parentheses. So the opposite of negative 2x, the opposite of positive 1, and we have a plus 1 hanging off the end. Well, these two 1s add up to 0, so we have 2x over 2, which equals x. So the g and f functions canceled out, and these two must be inverses of each other. So please move to the Google Classroom where the assignment is posted. There are a few problems about periodic functions out of the textbook, and there is that Regents review from the state of New York. On the Regents review, don't just answer true, false, yes, no, unless you have some kind of justification for it, some kind of work to show. Thank you for staying. And as said before, there is a problem with the quiz. It will be posted soon. This will give you a chance to do the review and check your answers before you take the quiz.